Welcome back. In this lesson, we're going to be working on pages 11 and 12 in your packet. And this lesson is all about proving similar triangles. So the angle-angle triangle similarity theorem. All this really says is that when two triangles have two pairs of congruent angles, the triangles are similar. So in other words, in this particular instance, we're being given that triangles A and D are congruent, and that angles B and E are also congruent. And because these triangles have two pairs of congruent angles, we know or are able to draw the conclusion that they're similar. So the symbols that we use to represent this AA similarity, really means angle, angle similarity. But in its very simplest form, we're really looking for two pairs of congruent angles. That's really the check. Do they have two pairs of congruent angles? If that's a yes, then the triangles are similar. If it's a no, then they're not. So again, what we're really looking for here, looking for two pairs of congruent angles. That's the test. So in this first example, where we're being asked to determine or to decide whether the triangles are similar by angle-angle similarity, the question that we are going to look to answer is if they have two pairs of congruent angles. So when I look at this first example, I see these fellows that each measure 102. I know that they're congruent. I see the second pair of angles, 30 and 48, but what I don't know is I don't know anything about this missing pair of angles at G and in N. And in order to find those, I'm going to remember that in a triangle, all three of the angles have to total up to 180 degrees. So now I'm going to get my calculator out, and you should too. And in the first triangle, I'm going to do 180, subtract 102, subtract 30. Or I could add the 30 and the 102 together and then subtract that sum from 180. But when I do that, I find that that missing angle is 48 degrees. And likewise, when I find the missing angle over here in the second triangle, either by doing 180 minus 102 minus 48, or either adding the 102 and 48 together and then subtracting that sum from 180, I find that the missing angle is 30 degrees. So now, notice that I have a pair of 30-degree angles that are also congruent. And at this point, I do have two pairs of congruent angles. So yes, the triangles are similar by angle-angle similarity. All I need is two pairs of congruent angles, and I'm done. All right, when I look at the second set of triangles over here to the right, I notice that I have in the first triangle an angle whose measure is 80 and an angle whose measure is 18. And in the second triangle, one that's 20 degrees and the other that's 70. So if I were to go and find the missing angles, I notice that in the second triangle, that fella is 90. In the first triangle, that missing angle is 82. And again, I found those just by remembering that in a triangle, all three of the angles have to sum up to 180 degrees. So the criteria that I need to meet is I need to have two pairs of congruent angles. And here I don't have any congruent angles. So to answer the question, no, the triangles are not similar by angle-angle similarity. Oh, this next example is really intriguing because when I first look at it, I know that I have a pair of congruent angles in the 55-degree angles. And that strategy that works so nicely for me in the first two cases, using the fact that the angles sung up to 180 in the triangle, doesn't work so well for me here because I only know one pair of angles. But one thing I have to remember from the last unit that we worked with is that whenever I have those angles that are formed by the x, the vertical angles, they're always congruent. And the one thing I like about math is that if in the last unit vertical angles are congruent, in this unit vertical angles are still always congruent. So those angles formed around point U, those vertical angles, they are always going to be congruent to one another. We don't know what their measures are, but we do know that they're congruent. And at this point now, I have two sets of congruent angles, meaning that my triangles are similar. And then the last example, again, I'm going to be looking for those two pairs of congruent angles. I notice that I have the right angles. Those, remember, would each equal 90 and would therefore be congruent. But in the first triangle, I have an angle whose met degree measure is 66. So again, I'm going to find that third angle by subtracting from 90, and I find that that third angle is 24 degrees. And in the second triangle, I can go ahead and I can do the same thing. 180 minus 90 minus 24 is going to leave me with 66 degrees. So I have my right angles, and I have the angles whose degree measure is 24, or maybe the angles whose degree measure is 66. Either way, I meet that criteria, and I have two pairs of congruent angles. So the answer to that is yes. All right, so now I'm moving onwards to example 2, in which case they want to know whether the two triangles are similar. Remember, the two triangles are similar when they have two pairs of congruent angles. So when they're asking if they're similar, what I'm really looking to find is if they have two pairs of congruent angles. So to answer that question, I'm going to say yes, because angles C and D, notice, are congruent. And angles A and E, notice, are congruent. So yes, they are similar by angle-angle similarity. And as far as the similarity statement goes, this is where I'm going to go and I'm going to match up the corresponding pieces, or the matching pieces. So I'm going to name the first triangle first, and I'm going to call the first triangle ABC. You can call it any order you'd like. You could call it triangle CBA, but I'm going to call it triangle ABC because that just sounds good to me. But now when I go to name the second triangle, I have to make sure I match things up. So the angle in the second triangle that matches up with A is E. So I need to put E first in the second triangle. The angle that matches up with C is D, and that has to come last, which means F is going to come in the middle. So again, just make sure that the pieces, or the order of these, matches up. So A matches up with E, C matches up with D, and then by default, B matches up with F. I like to use some color when I'm doing these also. So now side AB is going to correspond with, well, side AB connects my angle with two arcs to my angle with no arcs. So I need to connect angle with two arcs, E, to that angle with no arcs, F, in the bigger triangle. So side AB is going to correspond with side EF in the bigger triangle. And then DE is going to correspond with AC or CA in the smaller triangle. And again, that's going to be very similar to what we did with congruent triangles, except now our triangles are similar. But the idea of matching up the corresponding parts is exactly the same. So this should look a little familiar. All right, I'm going to go up to the top of page 12 now. You folks look like you're ready for a challenge, so let's do this. It wants to know, same kind of idea, are the triangles similar? So remember that when we're looking for triangles that are similar, what we're really looking for are two congruent angles. And if so, write your similarity statement. Once again, I'm going to employ the use of my highlighter here. So I've got really two different triangles. I've got triangle ABC, which is the big yellow triangle. And I've got triangle AED, which is the smaller green triangle. Those are really the two triangles that I'm going to take a look at. And in order to do this, because one triangle, the green one, sits on top of the yellow one, I'm really going to pull them apart and I'm going to separate them. So I've got triangle ABC. But here's kind of the important thing. When I pull them apart, I'm going to spin and flip and twist and turn the green triangle so that his orientation is the same as the yellow one. So in other words, I'm going to draw that obtuse angle in the same spot on the left. Let me get my highlighter out because I want to make him green. For instance, notice that I have this 120-degree angle at B in the yellow triangle. I want to match that up with a 128-degree angle in the green triangle. And that angle is at angle D. And then the other thing that I want you to notice is that this green triangle and the yellow triangle share an angle. Angle A is the same in both. And that's the reflexive property for angles. We haven't seen that so far this year. This is a first for angles, although we have used the reflexive property for shared sides. And then C in the yellow triangle, the only vertex I have left for my green triangle that would match up with C is angle E. But notice that angle D in the green triangle is my 120 obtuse angle. So again, now that I've drawn these so that all their matching pieces or all their matching parts correspond or match up. So now when I go to write my similarity statement, in my yellow triangle, I can write this however I want. I'm going to write triangle ABC, but now when I go to name the vertices in my green triangle or name the angles in my green triangle, I've got to make sure I match things up. So A in the green triangle matches up with A in the yellow. I'm going to name it first. B in the yellow matches up with D in the green, so I'm going to name him second. And C in the yellow is going to match up with E in the green. I'll name him third. So AE now in the little triangle is going to match up with side AC in the big triangle. And notice that AE is the right side of my triangle, and it's also the right side of my yellow triangle. And if I've drawn those correctly, those will match up. Side AB in my larger triangle, well, those are the first two. I get a different color up here. So should match up to side AD in the smaller triangle, and notice that side AB in my yellow triangle is the left side. It's also the left side of my green triangle, so there's some reassurance for me that I've actually drawn those correctly. That's a tough example. If you had a difficult time following along with that one, know that you're probably not alone. That one I think is a rough one. All right, you'll be happy to know that we have only one more of these, one more example to do here. This one too, we're going to ask you to pull back with some prior knowledge. Notice that I see that symbol here, the little railroad tracks, that means parallel. So we're asking you to go back for the first marking period on this. So segment AB is parallel to segment DE. So let me go find those in the picture. There's AB and DE. Notice that segment AB is larger than segment ED. So parallel means, remember, kind of that whole railroad track situation where they're going exactly the same direction, but they're not necessarily the same length. Are the triangles similar? So again, anytime we're trying to answer this question as to whether or not they're similar, we're always looking for two congruent angles. So I do have, remember, those vertical angles that live around point C. That's one pair of congruent angles. But remember too, and this is asking you to go back a long time, whenever we have lines that are parallel, remember that the alternate interior angles are congruent. So one pair of alternate interior angles would be at points B and E. So again, just a reminder from the very first semester that parallel lines have alternate angles that are congruent, or congruent alternate angles. And when we look for those congruent alternate angles, remember we're looking for the Z shape. And that's why we've got this angle at B and this angle at E. So are these two similar? Yes, they are, even though when we first looked at them, we didn't necessarily think that. And as far as the similarity statement, I'm going to put 3 arcs in the remaining angles, and then I'm just going to match up. So remember, I can always name the first triangle however I want, and maybe just to be different this time, I'll name it triangle CBA. But now in the second triangle, the angle that's congruent to C is angle C again. B matches up with E, so I'm going to name E second, and A matches up with D, so I'll name D last. And as far as the pieces or the parts that match up, side AC, well, he's going to match up to side CD or side DC, however you want to think about it. And then lastly, EC, well, EC are the first couple named. It's going to match up with side BC or side CB. They're one and the same. All right, so there you have it, folks. Pages 11 and 12 done. We're making progress. Thank you for the gift of your time, and I hope this finds you happy. I hope it finds you healthy and in good spirits, and I hope you and your loved ones are all doing well. Till the next time, Ms. McCann is out.